So we've got an aircon fault, a 2012 Nissan Qashqai. We're going to show you how to methodically test the aircon system using a fixed it method from Mechanic Mindset. I'll show you what we're going to do. Let's follow along. So, if you don't know who Mechanic Mindset is, it's Darren Quinn. He runs an amazing training course. We've only Barney through it already. So, we're going to use his methods to try and fix this car using the fixed it side of it. So, let's show you what it is. This is his fixed it methods. So, first one, you find your evidence, inspect the evidence, execute a diagnostic plan, determine the cause, implement repair, and assess. So, what was the point of change on this car? Now, that's his first one. You've got to ask the questions to the customer, do some investigation, find out exactly what we've got, get as much evidence as we can. So all we know is, so it's gone in, it's had the aircon regas, didn't cure the fault, so now he's booked it in with us. So the main thing is, what was the point of failure? Did it slowly get worse and worse and worse? Or did just one day it was cold, next time they turned it on, or while they were driving, it went warm, never worked again? When something like that happens, you've either got an electrical fault turning it off, or you've had the gas release very quick and it's a goner. So yeah, so if the air conditioning would have gone down slowly and then got to a point where it just didn't work anymore, fair enough. But if it's lovely and ice cold, then it's not cold at all, just ambient air, we know something's gone wrong, something's failed in that certain way. So that's what this one's done. Gone back in for the regas, done all that. So that is our evidence. That's the only evidence we've got at the moment until we start doing some testing. So it's had a regas and completely stopped. So the next thing is to inspect some evidence. So we haven't got much to begin with. It's not an intermittent fault. It's not as if like running faults and stuff where you've got to try and replicate it and that sort of stuff. With the finding the evidence, with knocking noises and going to limp modes and things like that, you can go through, ask customers questions, that's the main thing. Road test, visual inspections, all that sort of stuff, get the customer to show you what he's doing. But this one, no aircon, so haven't got to go that far in this one. So inspect the evidence. The only evidence we've got is it's been regassed and it stopped. And they're saying it's got gas in it, it still had gas in it, but we are going to double check that. Quite often, had it before, where they'll go somewhere, have a regas done, it doesn't work, so they remove the gas and don't charge them. So first thing we've got to do is check whether we've still got pressure in there, make sure we've got all the gas in there, and then we can go from there. And then we'll start doing some diagnostics. So let's get that checked. So there is some quite basic, easy checks you can do with aircon before you get too deep into it. But you've only got to miss a couple of steps and it throws you out. So if you can try and work in this methodical way every time, you should trip over it straight away. There are some corners you can cut, but it's not really worth it. I mean, it is only basic stuff on this. Well, basic checks to start with. It can get quite complicated when you got temperature sensors and stuff playing up. So had an Audi A5, I think it was. The flat motors inside, if it sees a fault on one of them, it'll turn the aircon off. And all you got to do is initialise them to let it set backwards and forwards, and they turn back on. They don't last, but if you overlook that, it won't work. Right, so we have got 3.5 bar of pressure. That's perfect. So we know our pressures are good. Let's see if the air conditioning is kicking in, see if the pressure's changed, see if we can hear a click from the compressor, have a quick look, see what system it's got in it. Then we'll do some investigation. When the compressor's not kicking in, the readings obviously should be equal. So just under 4 bar, just under 4 bar. When the air compressor kicks in, the high pressure obviously should go high, the low will go down, because that's going to be semi-negative. So, unfortunately not. Compressor's not kicking in. So, yeah, fair enough. Pressure hasn't gone up, obviously, because the compressor hasn't kicked in. But it was well worth keeping these on. If the compressor did kick in and the gauges weren't moving, then we'd look down that system. So now we know we've got to go back to the electrical side to see why it's not kicking in. Yes. So we know we've got gas. Compressor kick in? No. So that's all we know to start with. So in with the inspect evidence, we've got that evidence. Now let's look at some diagrams, work out what we got available to us, find out what system we got. Is it an electromagnetic compressor? Is it a valve type one? So we need to work out what we got before we do any tests. So let's have a look at that. Right, get an understanding of the system. It has got, you've obviously got the switch which you press. That comes from your air conditioning control module. That is your main switch. That talks to, so the only voltage it really gets out of it is to the blower motor itself through resistors, etc. It talks to the engine control module and the underbonnet fuse box by CAN communication. So it goes from there to body control, your multifunction control module 1. Instrument panel it talks to as well. I would think that's for the outside air temperature. And then talks to engine ECU, and then goes up to underbonnet fuse box, which has a multifunction control module in it as well. That is your main power down to your air conditioning clutch. That is an electromagnetic clutch on that. We run through a relay and a fuse. So it could be main air conditioning pressure sensor talks to the computer of the engine, the main engine control unit. That tells that. So we could check that with a scan tool, see if we got any fault codes for that. I mean, normally you would start around this area, but the fuse boxes on these, they're upside down. Not the easiest ones to get out and do some basic testing on it, but that's normally where we'd start. But I think it's worth giving it a scan. Some cars go into some sort of default mode when the gas is gone. So yeah, so let's scan it, see if we've got a pressure sensor fault or anything like that in the air conditioner, in the engine control module. If not, we'll see whether this is being told that you've pressed the button. If it is it allowing, or it thinks it's allowing pressure, a signal to go out down to the air conditioning compressor. So it's worth giving it a scan. It's going to take a few minutes. Better than flipping the fuse box upside down to check voltages, etc. just yet. Let's just make sure we sort of know where we're going with it. So we're going to give it a full scan. While that's happening there, this car come from a neighbour of mine who supported us on the channel since day one, when literally I had 5 viewers. He does a little bit of TikTok and stuff himself. In fact, he's quite big on TikTok on Kent Carp Fishing, I think his name is. Go check him out if you like carp fishing and TikTok-y stuff. But if you've ever seen somebody you know doing this sort of stuff, and you know them personally, you watch them, it's a bit cringy to start with because they don't know what they're doing. It's very, it's really hard to just get out there and put yourself on camera and stuff. I've seen people I know been on TV doing little documentary stuff, and you're like, oh no, he don't talk like that. Starts putting a tea into water, things like that, It's a bit rubbish. And you sort of got an opinion on them before you've even watched them. If you watch somebody else on there, you just watch what they watch. But this bloke supported me since day one. Come through, gave me some tips, and so just crack on, keep going. So yeah, well pleased with this. So I thought I'd better do a video on his car, considering he's watched them all since the beginning. So thanks very much for that, James. Right, let's have a look. Engine's got a lot of faults in it, but these do, They've always got multiplex system faults. They have a little pressure pipe which blocks up on these and stuff. We have got a refrigerant pressure sensor fault code in there, but that could have happened when they've degassed it. So let's report that. We're going to keep a copy of everything what's in there. Save that down. Just going to do a report. Also, let me show you this. In a lot of the Think Car stuff now, as you've got some bits up, you've got Arscleave. This is the AI side of it. They're trying to push hard for it. It's obviously self-learning, which is what AI is all about. So let's see if that does anything. It's thinking. Must be a bit like Barney. Takes a while. Fault code. P0530-116 is a Nissan vehicle, indicates an issue with air conditioning refrigerant pressure sensor. Steps you can do. Check the sensor, check the wiring, test the sensor simulator. Does it say common faults? Yeah, it's come up with some common faults. So obviously, yeah. So with a lot of AI, it searches it does a basic search, or it does a very good search. I use it a bit like Google, or gets rid of all the waffle. If I go on ChatGPT and put something in there, it says, ignore that, ignore that, ignore that. Actually, we have found this, we found that, we found that. So it saves you searching through page after page after page. When this starts getting good, if people start putting known fixes and stuff in there, it could become something. So yeah, just thought I'd show you that. Right, let's go into engine. So we've got quite a few different things, but we've got that P0530. They're all past fault codes. So let's go in and clear them all down. That's all cleared. Has anything come back? No DTCs. Let's read data stream, see if it's actually got pressure listed in there. It's got atmospheric pressure. Can't see refrigerant pressure actually listed in the rail pressure. No, it's not listed in there. Right, let's just start it. I'll flick the aircon on. See if any fault codes have come back. No, just a glow plug fault. It's common on this hands. So let's go into, so let's go into the under bonnet fuse box. Read data stream, all signals. Right, so we got air conditioning request is off at the moment. Start it up. And air conditioning compressor request is on. So it knows that we've pressed the button now. So that's gone from that to the engine ECU, confirmed everything in the engine ECU, and gone to the underbonnet fuse box to tell it to turn the compressor on. So it has been told that it wants to turn the air conditioning on. It knows that it should be turning it on. So let's go back to the diagram, have a look what we're going to do. So we know this is getting a signal from down here, which means it's talking through your multifunction control module. It's getting this signal to tell you press the button. It's gone through the CAN signal. I assume if it's telling it to request it on, that it knows that the pressure's okay. So we're going to have to go and check here, see if that relay's turning on, see if we got power to fuse 10, and see what we've got coming out of pin 23 on the underbonnet fuse box. So FIX, execute a diagnostic plan. So that's what we've just done. What have we done? So fault codes, DTCs, 0. So it doesn't mean anything. We knew what we was going to test and why we tested it. So switch is good. So we know that we're down to that point. Now we're going to go and just basically check. What do we have? Pin 23. Pin 23 on under bonnet fuse box. So let's check if we've got an output from the underbonnet fuse box. That will confirm a lot of things before we go down and actually look at the compressor. So let's get that undone. We'll have a look. But yeah, these are not so easy to work on. Shut up. There. Actually use these fuse boxes as the lid of the fuse box. And then have to flip them over to check fuses. Ridiculous. Well, we got it over. So we knew what fuse it was. Oh, we didn't mark that down, did we? What fuse did we have? Fuse 53. So have a look what we got. Okay, right, we're going to use a just normal test probe to see. Yep, we've got voltage on the fuse. That's okay. Right, let's mark that down. So the fuse is good. Pin 23. Let's have a look at that. Okay, it's got no earth path. That's a bit of a worry. So, right, so we've gone to that and it's showing no earth path. Let me just show you what I mean. So, earth path. Your air conditioning compressor is literally just a coil, an electromagnetic coil. So we've got an earth path to it, through the coil, and then back up to the underbonnet fuse box, and this is where it receives its live to then make that magnet, pulls it in. Probing in there, if this wire was good, compressor was good, and the earth was good, we should get an earth path there. But any of them failing, yeah, that's why we're losing that. But before we go any further, let's check that we are actually getting a voltage out of there when we activate the compressor. But I'm not going to activate it through the switch and everything. I'm going to go into the Think Car. You can actually go into activations in the underbonnet fuse box, actuation test, AC compressor, tell the compressor to turn on, then execute the plan. And there we go. So let's turn that off, execute, it's gone off. So without even the probe in there, you can hear it click the relay on. Just show you that. And execute. There we go, clicked on. And then this should click off. There we go. So that test has confirmed that the relay's clicking on. Now if we go in there with a probe, like I say, we've got no earth path on it. Let's actuate it on, execute test, and again we've got voltage down to it. So that's all down to a couple of things. Pin 23, underbonnet fuse box. Have we got voltage? Yes, 12 volt. So we've ruled out a load. We just need to go straight down to compressor now, see if it's broken wire to it, whether it's the coil itself, the earth to the compressor, who knows. So that's where they're going to go down to. So air conditioning compressors, they do three types really, maybe four, but old school style compressors, literally the electrics would turn the clutch on and off. So it would turn it on, it would have a friction plate and a pulley. They would pull together, both turn, spin the compressor up. Then when it got up to too high pressure, it would actually turn that compressor off and release the clutch till the pressures drop down, then it would go back on again. With that doing that a billion times over its lifetime, actually wears the clutch out or the front plate and the gap gets too big and the electromagnetic clutch won't allow it to actually kick in, and it won't allow it to get over that gap and actually put it in. If you do it and get it slightly closer, it will kick in the first time, and then once it releases, that's it. So yeah, so that's one way they do it. The next way they done it, they actually had a variable displacement compressor plate inside the compressor. So it would spin all the time. As the refrigerant went around the system, if you was putting a lot of demand on the air conditioning system, removing all that cold out of it, it would go back to the compressor at a different temperature. So if it come back nice and warm, because you've removed it all, and it's cooled it down inside the car, and you was putting a lot of demand on it, the plate would know, or the compressor would adjust to it and have a long stroke on all the pistons. Then after a while, if you turned it all down, it was only doing a little bit of work. As it come back cold, because you weren't using too much of it, the displacement would go and it'd have a tiny stroke on it. So that was another way they'd done it. The next way they'd done it, they actually put a valve in it so the ECU could control that valve on there. So that's the difference between the three sort of compressors. This is just a normal variable displacement electromagnetic clutch. So let's go down and check that, see if we've got voltage down there. Okay, right, we've got the plug off. Let's test what we've got on each pin. We've got ground on one pin, it's gone to the second pin. Activate it on the scan tool again. And there we go, we've got voltage down. So the coil's gone open circuit. We will just double check it, make sure no wires have fallen off the back of it or anything like that. Probe into the back of it, do a resistance check. But yeah, it's what it's going to be. We should really, the only thing we do now is load test them, make sure the earth and everything's good. But because it's open circuit, so because we know that we had no ground signal from there to there. We got the ground signal. If we had a volt drop, we would have some sort of signal up the other end, even if it was dropping away. But because it's completely open circuit, we know it's not going to be volt drop side of it. So unfortunately, yeah, it's going to be a compressor. So there we go. It is a compressor. The next thing is to determine the cause. That's what they would normally do. This is the part on my last video with the transporter. A few people have asked me why the wire had broken. I've actually questioned this with James Dillon. You get a certain fault in a loom on the same wire in the same place every time. And it can be a multiple loom, no vibration or anything, not rubbing, nothing like that. And he calls it harmonic motion. So must just be a certain amount of vibration in it. The transporter last week was down to the wire inside the trunk in there. There's like 5 or 6 wires all loose in there. So what I've actually done is wrap them up together. So now they all move together. Shouldn't happen again. So yeah, it is definitely right. You need to determine the cause to make sure it doesn't happen again. But on this one, was compressor failed? It's just old. You know, it is an electrical component that's failed. It's not failed for any reason. It's not rubbed through a wire, not done anything like that. You know, there's no cause what we can find that would have caused that. No effect what we can find what would have caused that to fail. It is just a old age part. Then obviously implement and repair. It needs a new compressor. And then, so we don't do that. It means degassing it, mechanical, etc. So he can go back to his normal garage and get that done now. And then you need to test to make sure you fixed it. Make sure that any fault codes, if you're doing intermittent faults, if you manage to replicate it the first time, make sure you can't replicate it the next time. Just literally to confirm that you've fixed the fault. So we won't do intermittent faults unless I can replicate the fault in the workshop or on a 10-mile road test. We won't take them on because I can't confirm that I fixed it, and I can't confirm the cause or the effect. Cracking a little bit of a diagnostic process there, fixed it, and yeah, go and check out Mechanic Mindset. It's good support of our channel as well. You could say, why didn't I go to the compressor straight away? Check live, check earth, it would have confirmed everything else. It is a quick, easy route. It's exactly the same as checking a horn, you know. But when you're getting more in-depth processes, more in-depth faults, using this the same way every time instead of trying to jump ahead and that lot, you know, it does smooth things out. You make sure you got the right readings, you make sure you haven't disturbed anything. If I'd gone straight to that, gone to it, got live, got earth, plugged it back in, it was working, would I've known what I've disturbed there. You know, we want to get as much evidence as we can before we touch the car, disturb the car, anything. So that's why we didn't go straight to it. And it was more to explain this process than to fix this car. So hopefully you can take something from this. Like I say, even on a basic horn fault with so many different things going on, you know, switches, modules, etc. This has explained a basic way of running through it to get to the end result. So yeah, hope you learned something. Thanks so much for watching. Thanks so much for James for bringing this car in and being a supporter of the channel. And we'll see you on the next one.